Whenever you're ready, go ahead.
All right, well, welcome everyone. My name is Jay Haferbecker. I've been with Greenheck about 26 years, mechanical engineer, and worn a few different hats in the company. Currently, I work with our software. I'm not necessarily a programmer, but I'm kind of that interface between our users and our programmers. Ultimately, my goal is to work with an engineering community on how to be more efficient in the design process by using our software. So thanks, Holden Associates, for letting me host or letting me present today. All right, so I've got a couple PowerPoint slides. So my agenda here is I'm going to give a real quick BIM and Revit overview. Specifically, I'm going to talk about the various LODs. Then I'm going to do a quick software or selection software comparison between our CAPS and our eCAPS programs, and then do a demonstration of our eCAPS, and then also talk about our Revit add-in with some demonstrations, and I'll show you how to get all this stuff along the way. If you got any questions, go ahead and type those in, and we'll answer those at the end. All right, so first we'll get started. I'm assuming a large portion of this audience is using Revit to do some of your drafting. And one of the things I wanted to talk about with this is this term LOD. LOD stands for the level of development. It's kind of the combination of that geometric detail and level of information provided. The American Institute of Architects came up with these 6 different LOD levels. And the reason why I wanted to talk about this is you're probably designing your Revit projects to a certain LOD level, and we have multiple levels of development available, and we want to make sure that we're lining ours up with yours, okay? Because if you're using a lower LOD level than of ours than what you're designing to, then you have to supplement that and spend time at it. Or if we're providing over level, a higher level, then in that case, you might be at a liability. So I'm going to run through each one of these LODs real quickly here. The first LOD is the LOD 100, typically used by architects in that pre-design stage. You know, we got the structure of the building laid out as far as its size, the sizes of the room, stuff of that nature. Not very helpful from our perspective yet. Then there's the LOD 200 level, typically used by plan spec engineers in that schematic design phase. We're designing for engineering intent, how much ventilation are we moving through the ductwork, that type of stuff. Then there's the LOD 300s in that design development phase. Okay, now we're making selections of the products. We're creating schedules of equipment. We're doing electrical coordination. That type of stuff happens at that LOD 300 level. Then there's the 350 level. Design build contractors fit into this. Design assist engineers fit into this as well. Now we're designing for construction documentation. Now it's not just the space envelope of the product itself. From a manufacturer's perspective, now it's how does that product interact with the rest of the building? Is it a flange connection versus a collared connection? That type of stuff happens here. Then there's the 400 level that contractors use to break down the building in its various disciplines and its phases. We're doing clash detection, all sorts of stuff at that 350 to 400 level here as well, and starting to fabricate the building itself. Then there's the 500s, typically used by the facility owners or the building managers. These are what we call the as-builts. The building has already been constructed. Third party is normally hired after the fact to update the Revit project and then add supplemental information like serial numbers of the products that got installed, replacement parts list, maintenance schedules, stuff of that nature. All right, so those are the 6 different LOD levels. Greenheck offers these 3 different levels, LOD 200, 300, and 350. This slide here represents, well, where would you go for those various LOD levels? If you're going to the website, you're going to get our LOD 200. You just pick a Revit family and the size and insert it, and away you go. It's kind of that placeholder. If you're looking for a 300 or looking to schedule, you could use our eCAPS or a Revit add-in. Since you're already entering in that performance and electrical information and making selections, why wouldn't we provide those as the parameters as well? Then there's the 350 level that you get from our desktop CAPS program, or you get that from the Holden Associates. They can send you over that content as well. Okay, so those are the various LODs that I wanted to talk about and familiarize yourself with. Next, what I want to do is I want to shift gears a little bit. I want to talk about our selection software. Now, you can have the guys at Holden Associate make selections for you, or if you want to make selections on your own, you've got one of two programs to choose from here. You can either select our eCAPS program or our desktop CAPS program. The slide here represents, what are the differences between the two. Um, the eCAPS program I'll talk about first, that's really designed around an engineer's workflow. And what is that? Make selections of products, but ultimately make selections of products to populate onto a schedule of equipment for the contractor to purchase and install. So knowing that, we made it simple, fast, and intuitive. We provide just enough information to populate that schedule. It is an online program, so nothing to install. You just go to the website and it works. We added some optimization tools in the program where we kind of guide you towards that best value product, and I'll give you some examples of that in a moment. And then also we added some tools in there to help keep you out of trouble on test and balance day. We've got a lot of experience with making great selections, and we try to automate as much of that as possible and steer you away from those troublesome areas so you don't have a problem on test and balance day. And it's got all of our core products in it, and it also links to our Revit add-in. Now, to contrast that with CAPS, CAPS is really designed around the local mechanical rep like Holden, for example. And what's their workflow? Make detailed selections, provide detailed submittals for final submittal approval, um, uh, really get into the full access to all of those options and accessories, but ultimately, provide those detailed schedules, and then also work with the contractor and on the purchase price and multiple order splits and all that kind of stuff. But the point here is we made this also available to the engineering community. We simply turned off the ordering and the pricing capabilities. So kind of I like to sell that as, hey, these are advanced selections. I really want to get into every model and every accessory and everything that's available under the sun. Not quite as easy to use because you kind of know what models that you're looking for, where eCAPS has got some of that guided flow in it. It is a desktop program, so it's installed on a PC. It does include all of our products, including kitchen hoods and some others, but they get kind of complex to make selections of. I typically recommend getting Holden involved anyhow, and it has a slightly higher level drafting detail as well. At a really high level, I would typically recommend if you're a plan and spec type engineer and you work with that workflow, eCAPS is a better program to use. If you're a design build contractor, then CAPS is probably the better program to use. You can mix and match. You can make a selection in eCAPS and send it to CAPS if you want, and I'll show you those capabilities here in a little while. But those are just general rules of thumb, and you can use both programs if necessary. All right, so with all that being said, I'm going to focus on our eCAPS program, and my last PowerPoint slide here is this one. And this kind of gets into that guided flow that we talked about. Just from a fan's perspective, we've got over 10,000 different models and sizes of fans to pick from. Now, we got a lot more than just fans, but we're going to focus on fans today quite a bit. So envision this triangle on the screen there as a funnel, okay? And at the top of that funnel are those 10,000 selections. And what we do is we ask you just the right questions along the way to guide you towards that best value product. That's that delicate balance between a great performing unit, but not at a huge price premium either, and then also having a stable selection. So that's kind of what our eCAPS program does. So next I'm going to do is I'm going to do a demonstration of our eCAPS program itself. For those of you that don't have it, you simply just go out to this website, ecaps.greenheck.com, and this is your default screen. You don't have to have an account. You don't have to register if you don't want to. You don't even have to log in to use the majority of the program, but there is value in being logged in. You can save your selections to use later. You can share your projects with others. You can customize some screens and schedules and so on, and I'll kind of show you that as we go. So the first thing I wanted to point out here, as you'll notice that some of these products here, these groupings, have a little Excel icon in the upper right-hand corner. That means those products you can make selections and you can schedule in Excel directly from eCAPS. The products that don't are more guides. We guide you towards what models to use. We still have cut sheets available, still have drawings and that type of stuff all available underneath these others, but these you can actually create a schedule for. All right, so let's get started. I'm just going to pick a fan, okay? And then we get subcategories of fans, right? So we can pick anything from a blower to a roof exhaust or inline. I'll just do an inline example. So we're starting to walk down that funnel a little bit. I'm going to enter in some random performance here. We'll just do 5,000 at 2 inches of pressure. It's running through all of our inline selections. There's a couple thousand in this category, and it's going to return only the inline fan sizes and models that meet that performance of 5,000 at 2 inches of pressure. Okay, and once it's done here, it's going to show us our selections. And in this case, we've got 45 fans that meet that performance that are all inline. Now, as a general rule of thumb, pretty much all fans can be used for general clean air applications, but some of these fans can have provisions for other applications, and that's where the second accordion comes in. If we open that up, how do we want to apply this product? Do we have an application that requires smoke control or a seismic rated requirement, or are we using it for restaurant exhaust or spark resistant, etc.? And I'm not going to read them all off, but I think you get the idea. The idea here is if we pick one of these features, it's going to narrow my list of models and sizes down that can meet that. Okay. All right. So we also added some comparison tools in here. Maybe I'm interested in these top three selections, for example. I hate to compare in here, and I can get an image of what the three look like. I can look at my intended application. I can look at my space envelope here real quickly. I can see the overall height of these here. If I'm trying to fit this thing below a 30-inch tall space above the ceiling, you can see you got two of them that'll work. This other one won't. We got fan curve comparisons. We got sound chart comparisons by octave band. Some octave bands are easier to attenuate or are more or less important than others. You can see all that here as well. All right, which leads me to my next point. The order at which these fans are in is really important, okay? Most manufacturers will just try to push you towards the least expensive fan. The least expensive fan is probably a smaller wheel diameter fan. It's probably spinning at a higher speed, requiring more brake horsepower and producing more sound. Not necessarily the best selection. So what we do in eCAPS is we're trying to guide you again. So we're coming down that funnel, right? And so what we do is we rank our selections, okay? And this is where that best value piece comes in. So what we're doing is it's not just single dimensional, it's three-dimensional, okay? We take into a component from a performance perspective, efficiency, best measured by the lowest brake horsepower, kind of built into that efficiency component, and also kind of your operating cost and your FEI, fan energy index. Those are all kind of measurements of efficiency, okay? The next measurement that we take into account in that ranking is sound, okay? So we use inlet zones, or you could use dBA, just a different measurement of sound. Either way, sound is important. So that's the second metric that we use in there. And then the third one we use is the budget price. Budget price is shown to you. This is a rough estimate of how much this thing is going to cost. If you want an actual price quote, get a hold of the guys at Holden there. I can give you an actual price quote, but this is supposed to get you in the ballpark and the magnitude. So if you notice, these first half dozen ranked items, kind of hover around that $5,000 price point. As I dig deeper in the list here, meaning less recommended, notice that price goes up significantly. There might be a heavier constructed fan. These fans can be used for general clean air, but maybe they're more intended for, heavier duty applications. So that's kind of why they're ranked lower. Now, if we microanalyze these top half dozen ranked items, you'll notice that the top ranked item isn't necessarily the least expensive. These two products here are slightly less expensive, but what am I getting for that extra $75 roughly? I'm getting a more efficient fan, right, in comparison to these other two. And I'm also getting a noticeably quieter fan, right? So if I get roughly a half brake horsepower less and roughly a third less in sound for only $75, that kind of seems like a no-brainer to me. This is a pretty good, solid selection. All right, so that's kind of what the ranking does for us. Now, the last thing I wanted to talk about that gets us right to the point of that funnel that we were talking about earlier is you'll notice that some of these selections have caution icons next to them. That means there's something to be concerned about with those specific selections. And this is kind of where we talked about trying to keep you out of trouble on test and balance day. So if we click on one of these, it tells us what the concern is, right? In this case, it says my operating curve is within 12% of the max system curve. In this case, it's actually at 2%. Let's go take a look at that fan curve. So in this case, would you pick that selection? I hope not. This is very close to being unstable. It's riding that line really close. Anything in the gray region is truly unstable, and we won't allow you to make a selection in that gray region. But then we put a tolerance on it from that gray region down to about where my cursor is. So if you're operating anywhere in that range, we're going to caution you on that selection. You can still have it if you want it, but be concerned that it is cautioned. The reason why we still show it is it might be a replacement fan, or it might be a tight building constraint. That's the only one that physically fits, or maybe you're running on a generator. I mean, there's a half dozen reasons why you might still need that one, so we still show it, but you've been cautioned. So that's one potential trigger of 5 for a caution icon. Some of the other icon ones that could show up would be if my RPM of the wheel is within 5% of the maximum speed of that wheel. Basically, rather than your fan curve being maxed out, now my wheel is maxed out. The next one deals with your motor. Okay, if the brake horsepower is within 10% of the max motor size for that fan, will caution you in that selection as well. And there's a couple other caution icons as well. They're a little bit more complicated, but the idea here is we're trying to keep you out of trouble. All right, so those are caution selections and what those are all about. So we're at the point of that funnel now, and this is the one that we're recommending, and you can pick any one in the list if you want. We also added some other filtering criteria in here. We talked about the ranking, but maybe I don't want to have a fan over 3 brake horsepower, and my FEI needs to be at least 1, and I don't want to have a fan that's louder than say 22 sones, for example. Let's make it a little tighter, 20 sones, for example. And I don't want to spend more than maybe $10,000 on a fan or whatever. Okay, well then these are the ones that are all filtered out for you on that as well. Okay. All right, so that's a little bit about how to make good selections. If I want to know more about any of these, we can click on it, and it gives me a bigger description. It gives me my specific fan curve, and I can take a look at min, max speeds, RPM families, all that. We got our dimensions and space envelope here, overall length, width, height, and connection sizes. And then we got downloadable drawings. We got a 2D AutoCAD, a 3D AutoCAD, Revit content in both the 200 LOD and that 300 LOD that we were talking about. And maybe if you're doing the selections and someone else is doing the drafting, you can just email all button there, and you can send that to the drafter, and they'll get a copy of all these drawings. And then we also can generate cut sheets is here as well. All right, so if you remember correctly, our ultimate goal here is to help you populate a schedule of equipment for that contractor, right? So if this is the item I want to add to my schedule, I simply hit the add button, and now I need to tag it, right? So maybe this is inline fan -1, and we pick our power supply. So maybe we're dealing with 208 volt, and then we hit add to schedule. And so in this case, I got one item in my schedule. So now if you want to add more products to your schedule, you can either just add another one of these same products, or we can come over here to this little plus button here, and we can start over from the beginning part of the screen, or we can use the breadcrumb trail and go back 1 screen or 2 screens, to start all over and add more. All right, so for the sake of time, let's just pretend that our schedule is done. I know we only got one fan in our schedule, but let's go take a look at that schedule, okay? Now, I'm not sure how each of you schedule, but I'm going to talk about 4 different scheduling techniques. Okay. The first one I'm going to talk about is for those of you that use Excel for scheduling. Okay. And for those of you that are using Revit, I'm going to show the Revit add-in later and how we can schedule within Revit using 3 other techniques. All right. So for those of you that are using Excel, the first thing here we want to do is each one of your companies probably has your own schedule layout, the columns in a certain order and certain column headings. So first thing we want to do is come over here to our column chooser. This is this customized grid button. And basically what we've got here is these are all of the columns that you could schedule. Now we default to the most common scheduled columns, pre-checked, but you can tweak that, right? So maybe I don't want to schedule drive type, but I do want to schedule my full load amps and maybe my MCA, for example, for electrical coordination or whatever. Then we can come over here. Now we can select the order at which we want those to appear. So maybe we want all of our electrical information, to be next to each other. So I just drag and drop, and I hit the OK button, and now it reordered my columns on screen. Okay. And the next thing that we typically see in a schedule are schedule notes, right? So down below here, we have a library of schedule notes. We have a pre-canned list of 9. schedule notes, but you can add as many notes down here as you want. So for example, I could come down here and in note number 10 there and add, a VFD rated motor, and I could add a whole bunch of other ones here. You can see there's lots of white space. There's room for about 30 of them. And underneath that scenario, if you're logged in, it will remember your schedule layout, as in the columns that you selected in the order, and your library of notes. That's a one-time event for every job going forward, right? All right, so that's our library of notes, but we haven't scheduled any yet. So that's where we come up here and we add a note. So maybe I want to add that backdraft damper to this inline fan, and I want to add a disconnect switch and maybe some vibration isolation, for example. So now we got notes number 1, 4, and 9. All right, so let's just say we're done. Next, what we want to do is come over here and save this job. I'll just give it a test A, B, C, D, for example. And so I'm logged in. So this is saving it to my account out in the cloud, so I can access this from anywhere in the world. So maybe I'm working at home one day and I want to, go to the office tomorrow and see my selections, or vice versa. You can do that. All right, so now that we got it saved, we can do lots of reports and other things. And if we're not familiar with what these little buttons or icons over here on the left-hand side, we can slide that out and we can see what these are all about. So I'll cover several of these. The first one I want to talk about is downloading some documents. Now we're kind of focused on the schedule right now, so I'm going to create an Excel schedule. And so what it's doing is it just created an Excel schedule. Now I'm going to open that up and let's take a quick peek at it. And once that's open, we'll see that the columns that we added before, for example, remember we added the NEA full load amps and also the MCA, and then we also got the notes here, and then it's got the definition of the notes. And notice it renumbered them, because I think we had 1, 4, and 9 or something of that nature. It plucked out those numbers that we don't schedule, who's going to actually skip numbers in an actual schedule. Now, keep in mind, we've only got one fan on this schedule, but if we had 5, 10, or 15, they'd all be shown here as well. All right, so that's how to schedule. A couple other things before I leave schedules. We've only talked about fans so far, but we do have a separate schedule layout for gravity products with their own set of columns and notes. Same thing for louvers, our dedicated outdoor air systems, or DOAS, our high volume, low speed fans. We got our makeup air fans, our products, and also our energy recovery. Now, we don't have any of these products in the job, so my Excel spreadsheet didn't include those, but if I would have had any, it'd just been a different sheet within the Excel spreadsheet. Okay. All right, so that's how to make a fan selection. One other thing that I wanted to cover before we leave this screen is if we wanted to share this project with someone, either within your own firm, for example, or you wanted to share it with Tracy or one of the others at Holden Associates, we can come down here and share that project. Basically, we type in their email address and then a subject, maybe this is Washington school that you're working on, or whatever the case is, and hey, please give me up price quote or availability check, or whatever, and send that off. And whoever you send that to is going to get a copy of your job. And they can do one of several things with that job. They can open it in their own eCAPS software if they want, and make tweaks to it, review it, whatever, and save it. Or they can import that into the CAPS program and pick additional options and accessories. But either way, when you do share that job, it's always a copy of yours. So if they make selections, they have to send those back to you, and you have to accept those in order to know that there's any changes or anything happening there. Okay. All right, so that's fan selections. Next, what I want to do is I want to talk about our toolbox over here on the right-hand side, okay? Now, our toolbox is specific to whatever product category that I'm on. So I'm not on any product category right now, so it's fairly generic, right? It kind of walks you through that. There's a video here that talks you through how to create an Excel schedule, basically what I just showed you. There's some other videos and helpful tools there. There's how to get the Revit Add-in. There's some online courses for PDH credits, etc. But let's say if I click on one of these categories here, fans, for example, notice my toolbox changes. Now, these are specific to fans. And one of the tools that I like to highlight is our System Effects Simulator. Okay, when we test our fans here at the factory back in Wisconsin, we test them underneath ideal installation conditions. Nice, smooth, straight flow in and out of the fan, right? The fan's always get installed that way, right? Well, not necessarily. What happens? The contractor has got some tight building constraints, so they put an elbow at the inlet or outlet of the fan, or there's a number of reasons that can cause system effects. So we try to avoid those, but In many cases, we can't, okay? And so what the simulator does is it helps us quantify how bad is this system effect situation going to be. So to use this thing, first thing we got to do is pick what category that we're working with. Are we working with an inline fan or a roof exhaust or a blower? The math behind the scenes to calculate system effects is different for each one of those. So let's just pick a blower. And notice we have no inlet conditions initially selected, and I can select from ductwork to elbows to wall obstructions. And on the outlet, I've got nothing selected, and I can select from ductwork and elbows as well. So I'm going to come over here, and I'm just going to take a sharp elbow, and I put that immediately at the inlet of the fan. So the air is coming from up above and taking a 90 degree and right into the fan. We all know that's bad, right? But how bad is it? Well, if we look over here in the upper right-hand corner, we can see we're going to have a 7% impact on that volume flow rate, or the CFM, coming out of the fan, right? So 7%, test and balance day, what's the typical solution? Speed it up, right? I'm not suggesting that that's the best solution, but that's the typical solution. So the test and balance guy comes in, and if we're short by air by 7%, we need to increase the RPM by 7%, right? Using that first fan law. Okay, the RPM and CFM are directly proportional. But what happens to your brake horsepower requirement as you increase that RPM? Well, that goes up by the cube of those RPM ratios. In this example, your power increase is going to go up by 23%. Okay, that's a pretty big number, Most fans aren't oversizing their motors by 23%, so you probably don't have enough wheel to spin the motor that fast. That's why system effects are so important. I can sit here and talk till I'm blue in the face, hey, we're redesigning some of our fans and we're coming out with better wheels and better performance and FEI and all this stuff, right? And get a couple extra percentage points of efficiency, that's all great. But if you don't get the fan installed correctly, I mean, you could blow 23 percentage points just like that. So that's why system effects are so important. Okay, so two big use cases for the system effect simulator. The first one is maybe I'm working with the building owner or the architect, and we're trying to justify, well, I need an extra 3 feet in my utility closet for some straight ductwork because I want to prevent that elbow, right? And so you can print this thing off. There's a print button up here and just have that conversation. Hey, if we don't get an extra 3 feet of space here, we're going to have a 23% increase in the power consumption for the entire life of that fan. Maybe that's persuasive enough. Maybe it's not. Your engineer. I mean, your building owners and architects better than I do, but at least you can have that conversation. Okay. That's the first use case. The second use case deals with the fan already being installed, and maybe you get that test and balance report back, and hey, we can't commission the building because this fan is out of tolerance here. We're short on air by X%, right? So you could come in here and you could simulate, well, what's my current condition? So in this case, we got that elbow at the inlet of the fan, and yet we're over by 23% on our power consumption, etc. So now what we can do is we can come down below here and we can look for situations that are in green. So that means if I go from my current condition up above to any of these green conditions, that's going to improve my situation. Now, the bigger the number in green, the bigger the magnitude of change, right? So in this case, we can see you got lots of opportunities to make an improvement, right? So it's real common for someone to come over here and try to add some ductwork between the fan and the elbow itself. And now notice I'm only over by 14%. That's a fairly significant increase, but we're still over by 14%. So we can look for other, now I forgot to mention this, any numbers in red means I'm going to make it worse, right? So we can come back here, well, we could swap out that sharp elbow with a smooth elbow. That gives me a couple more percentage points, or maybe we want to put a 45-degree elbow on it instead, or maybe we want to remove that elbow. But notice we're still over by 10%. Well, look at, I got some other advantages over here. I can add some outlet ductwork to it now and finally back to my rated performance. So you could use this as an educational tool to find out, well, how were these fans originally installed and how are they intended to be installed, and that type of stuff. I don't think it's obvious that, hey, I got to have ductwork on the outlet of a blower in order for it to perform properly. That's not a Greenheck specific thing. That's an industry thing. All blowers are tested with ductwork on the outlet. If you don't have that ductwork on the outlet, you're going to lose, 2 to 10 percentage points of efficiency on that. You don't have to take our word for the numbers. What we did was we basically took one of our fans and we ran it through the AMCA publication 201 02, and we put a little graphical user interface on it for that. So this is an industry accepted standard for how to calculate system effects. So it's not a Greenheck thing, it's an industry thing. One key thing to keep in mind is focus on these percentages over here on the right-hand side rather than the magnitudes of the numbers down below. The magnitude of the numbers down below are designed or based upon these performance points, but your percentages are fairly steady regardless of the performance point. So that's one of the tools in our toolbox, our system effects simulator. I hope you found that of value out of the eCAPS program, and there's lots of other tools in there as well. All right, so at this point, we've done a quick demonstration of our eCAPS program. I recognize that I focused on fans so far, but before I dive into any of these other products, what I thought we'd do is we'd switch gears and talk about our Revit add-in. Now, for those of you that are using our Revit add-in, you know, might be familiar with it, but you know, I'm gonna run through a demonstration of it. But the whole premise behind the add-in is you can make selections of our products, you can insert Revit content, and you can schedule from Revit with never leaving Revit in the first place. It's a big time saver, right? So think about your typical workflow now, and I'm not sure if it's the same for all of you, but you know, very commonly I hear, oh, well, you know, I'm using Revit, I need to go find some content, so I exit Revit, and then I open up some third-party software like CAPS or eCAPS or maybe, you know, someone's website or whatever. Regardless, you're leaving Revit and you're making a selection somewhere. And then you make your selection, they have to find where the Revit content is for that selection, then you need to download it. Okay, typically when that's downloaded, it's probably a zip file, right? So you need to unzip that file and save it somewhere, maybe a network drive underneath your job folder or whatever the case might be. And now we need to go back to Revit, and now we need to go find that content, and hopefully you didn't get a phone call in between or anything, and then bring it into your Revit project and then place it on your project itself in the building, right? Or on it. That can take a significant amount of time. So keep that in mind when I'm demonstrating this Revit add-in on your current workflow versus what this new one's going to be. So, all right, so here's Revit. I'm going to talk about how to get the Revit add-in installed later, and I'll show you it works with multiple versions, etc. But I want to show you how to use it first. Okay, so once you get it installed, you'll notice that we have a Greenheck tab up here in the Revit toolbar up on the top in the up here, and I'm going to talk about most of these buttons. The first three buttons I want to talk about are these on the left-hand side. These are how we get Revit content inserted into my Revit project. The first one I want to talk about is select by model. Okay, select by model. The use case here is you probably know exactly what model you're looking for. So if we click on that, what that does is it links out to a live directory of hundreds of Revit families. There's hundreds in here, right? And this is basically the same content we have on our website. It's just you don't have to go to the website. We got filtering in here, maybe only show me air terminal units, or only show me diffusers, or only show me fans, or whatever, okay? Or if you know what model name you're looking for, maybe you're looking for a model BSQ. You know, that's our most popular inline fan that we sell, for example. And then we hit the insert button. And now we need to pick our size, or we can multi-select if you want. I'll just pick one of these here. And what it's doing now is it's bringing that Revit family into my Revit project. It's pre-picking that specific size, and then it's placing it on my cursor. And now I just simply click and I place it in my building. Okay, and now my first product is installed or you know inserted in my Revit project. I mean, look how quick that was. I mean, we probably did that in what, 30 seconds or so. Pretty quick. We didn't have to exit, we didn't have to zip or unzip, store anything, none of that. It's all there. So that's one way. This is an example of our LOD 200. Okay, that's that space envelope of the product. There's no performance, no electrical information associated with the LOD 200s. All right, so that's one way to get content in. The next one I would talk about is select by performance. This is if you're looking for an LOD 300, or maybe you don't even know that you want a BSQ, much less what size it is. So what this does is this links out to eCAPS. So everything we learned earlier applies here as well. So for example, maybe I'm looking for a fan this time, and maybe it's a roof exhaust fan, and you know maybe I'm looking for 6,000 CFM at 3/4 of an inch in this example. So that's going to go ahead and make that quick selection. Everything else that we talked about earlier still applies. We can select our certifications and special requirements. You know, we have our ranking, we have our caution icons. All that stuff's the same. The only difference here is that we have a little Revit icon here rather than that little plus sign that would have added to the Excel schedule. So if this is the one that I want, I simply hit the hit that button. I need to tag it naturally. So maybe I want to give this EF-1, for example, and I pick my power supply. I'll pick 230 volt this time. I can generate a cut sheet right now if I wanted to. That would create a PDF of it, and you just save that wherever it prompts you to save it at. And once this thing's done thinking, then we'll hit the insert button, and that'll bring it right into our Revit project, just like the other products. All right, so in this case, it's going to bring that Revit family into my project. It's pre-picked that size. It's bringing in all of the parameters, and now I place it on my building, and voila, there I'm done. This is an example of our LOD 300. So if we come over here to our type properties, you can see we have the electrical information underneath the electrical section, and we have all the parameters for our mechanical flow that you typically see on a schedule, CFM, pressures, um, FEIs, all that stuff is there. And I'm going to show you how to schedule here in a few moments. So that's how to get the LOD 300 in there. Now, the next thing I wanted to talk about is some idiosyncrasies here that or some neat advantages that may not be obvious. The first thing is that big box around the outside of each one of these inserted products here. What is that? That's the service area clearances, right? I can turn those off individually over here by the checkbox, or I could turn them all on or all off up here in the speed buttons up above, okay? The next thing I wanted to talk about is we allow mild configuration for some of these products, okay? So for example, this is a roof-mounted fan that comes standard with a 12-inch tall roof curb. So we can come over here and we could turn that roof curb on or off if we wanted to, or we could even change the height of it. So maybe it's not a 12-inch tall, I want a 24-inch tall, that automatically updates. So that's an example of some mild configuration we have. That's what we got for this product, but you get into a blower and you can change the wheel rotation and the discharge positions. The inline fans, you could add, vibration isolation, or there's some other things that you can add, like a filter box and stuff of that nature. So I just wanted to talk about that briefly. All right, the next thing I wanted to talk about is the third way for inserting content. So in this case, if we have a previously created eCAPS job, for example, we could insert that one as well. So if you remember correctly, I did test A, B, C, D, and so we could select that job because I saved it in eCAPS, and this is, remember, our linking from eCAPS to the Revit add-in. So once this job's done loading, I can take the products one by one, or I could insert all of them at the same time. If I do one by one, then what that'll do is it'll actually ask me where I want to place it on my cursor. Or if you do all at the same time, then it just brings them all in. You got to drag and drop from the project menu. All right, so that's the third way to get content in. A couple different use cases there. The first use case is maybe you want to make all your selections in standalone eCAPS first and then do the drafting later. Or maybe you want to do all of the selections and you could email that project to the drafter, and the drafter then could open it and save it in his project and then insert all that content as well. It's a couple different use cases there. I'm not sure how each of you are set up, but you got some options there. All right, so that's how we get content inserted. Next, what I want to do is I'm going to shift gears and I want to talk about how to schedule using Revit, okay? We talked about how to schedule using Excel earlier, and now I'm going to show you three different techniques within Revit itself. Now, the first technique is the easiest one by simply just creating a Greenheck schedule using Greenheck parameters. Very similar flow to how we did it in eCAPS. We pre-picked several of our schedule columns here, but again, we can tweak that. So maybe you don't want drive type, and maybe you do want your full load amps, and I want my full load amps in a certain order. And then we come over here and get create schedule, and voila, now it creates my smart schedule. Okay, so now as I add more Greenheck fans to my project, they'd automatically show up in here. If I delete an instance out of here, they would delete out of here as well. And now this is a Revit schedule, so you have all the same formatting capabilities that you would have with any other Revit schedules. If you want to move your columns around again, or if you want to change the names of the columns or your units of measure, from imperial to metric or whatever, you can do all that stuff. All right, so that's one technique. This works really well. As you can see, it's really fast, really intuitive. Where it might not work well is maybe you already have your own schedule using your own parameters, or you have a mixed bag of manufacturers in your Revit project. That's where the second technique comes in. So what we're going to do in this one is we're going to create a mapping. Okay, so we select Create Mapping button. And underneath this use case, you probably have your own shared parameters file. Okay, so what you do is you'd load that right here. Okay, so I happen to have one mocked up just as a sample. Let's see here, where did I store that shared parameters? And so what we're going to do is we're going to take this first column over here on the left is the Greenheck parameter, and we're going to map to the third column your shared parameter. So I'm going to pick on Greenheck's BHP. And let's say that we want to map to your brake horsepower. So what's going to happen is we're going to map the value from our BHP into your brake horsepower. And you could do that for whatever fields you want to do. I'm just doing this one. And then you hit the apply button, and then that's mapped. And that is a smart schedule again. So as you add more Greenheck fans, that BHP value is going to map into your brake horsepower value that you would have on your schedule. Depending upon how far you want to take this, we added some additional features in here. You could have different mappings for each one of the product categories that we have here. You could also save this configuration so you don't have to do it again on the next job. Okay, so you could apply that mapping or open that mapping in the next job, or you could apply this to your Revit template for every new job that you start anyhow. It depends on how much you want to adopt it. So that's the second technique and probably the most common technique. Basically, we're mapping our parameters to your parameters. Now, the third technique is the complete opposite of the last one I just talked about. Underneath this use case, normally what would happen is you would have a stripped down Revit family. Maybe you create it yourself. Maybe you're using one of our LOD 200 families. Either way, it's kind of the same thing, but you really have no parameters of ours, and you want to use your own parameters. So in this case, what we're going to do is we're going to take one of your shared parameters and put it into our family. It's the opposite, you see. So in this case, you need to load your shared parameter file, which in this case, it remembered from my last step. If it didn't remember it, you would click it here. And I'm going to pick on your brake horsepower field again, and I'm going to put that into my BSQ LOD 200 family. And so we just hit the apply button, and then what happens there is we take your brake horsepower field and put it into our family. Not necessarily a smart schedule anymore because you have to populate that brake horsepower value. And maybe you have some techniques set up for that where maybe you're using Excel and you're linking that to your parameters and you're bringing that in or copy pasting it. And then you would actually then in that case then put it back into our family. It's a roundabout way of doing it, but that is a technique that is commonly used. All right, so those are the three different scheduling techniques that are commonly used in the Revit add-in. Now, the last thing I wanted to talk about here before I show you how to get it installed is I wanted to talk about reselections or how your jobs evolve. Okay, this particular fan here, we selected this one initially at 6,000 CFM at 3/4 of an inch of pressure. But let's say our job is evolving and maybe I want to add an additional 500 CFM to that fan, for example. So we want to do a reselection on it. Normally you do is just delete it and start all over. But in our case, what we did is we added this reselect button. And what that's doing is it's remembering all of my original inputs. It's going to remember, what my volume was, what my static pressure was. If I picked any of those certifications that we talked about, like restaurant exhaust, for example. It's going to remember my voltage pick that I originally had. It's going to remember, my tag name, all of that stuff. And it's going to reselect this thing and it's going to re-highlight the original row that I had selected in my grid. And then from there, now we can modify it. So once this thing takes about 8 to 10 seconds to do here, once that thing's done, now what we can do is we can come on here and say, well, now I want to add 500 CFM more. And what it's doing now is it's trying to reselect that same GB 220. If that same size is available, it'll pre-pick it for us. If it's not, a message will come up saying, oh, you got to pick a different fan. We'll see what happens in this example. So in this example, it's still available. It's now ranked number 2, and it also has a caution sign. So we click on that caution sign. It tells us, in this case, within 5% of my maximum RPM or speed. So maybe we want to avoid that selection. So in this case, let's go with this GB 260. If we take a look at it, fan curve looks good, you know, the dimensions look good, all that stuff. So in this case, what we'll do is we'll go ahead and we'll insert that one. I remembered my tag name, everything else. And in this case, now what it's doing is it's going to stomp right over the top of the old one. Message comes up here saying that if you have any other EF1s already in your project, it's going to stomp over those as well. If the ductwork was connected, it would reconnect those. If my power supply was connected to my circuit panel, it would reconnect all those as well. And also notice it updated my schedule because I'm using Smart Schedule. So that's a quick reselection of the products. All right, so that's most of the features and functions of the Revit add-in. Again, I focused on fans, but it does a lot more than just fans, just a demonstration of fans itself. So next, what I want to do is I want to show you how to get this. To get the Revit add-in, what you do is you go out to greenheck.com, okay, and then you'd come underneath Resources. And underneath resources, we got the software section here. So I'm going to click on software. You can click either here or in that left-hand panel. And then, oh, I didn't actually, I must have clicked on something else. I'm sorry. So if we click on software, then this is all the software. If you want to link to eCAPS, this is where you'd get that. If you want the Revit add-in, we call it our eCAPS bridge for Revit because we're connecting the two together. We would click here. If you want our desktop CAPS program, you'd get it here. If you want our coil selection software, we got that, and a cycle chart calculator as well. But in this case, we're focused on the eCAPS Revit add-in. So here's my page. Here's my installer down here. I click on that and it installs it. It works with 5 versions of Revit going backwards, so 2020 through 2024. I recognize 2025 came out here in April. We are in the process of releasing that hopefully in the next couple of weeks to be on 2025. If you install it on one of the versions, it will install it on all of the versions that you have installed, assuming it's in this list. So that's how we get the Revit add-in. All right, so that is what I had planned on covering. We covered our LOD content and what those are. We covered some basic fan selections in eCAPS, including how to share them and our System Effects Simulator. And we covered our Revit add-in and how to get it installed. Again, I recognize I focused on primarily just fans. Time permitting, I could cover some of these other selections, but I thought maybe what we do first is open it up if there's any questions that I could answer first.